Hello, this is WF7i Homebrew. Been kind of a long time without any ability to really work on this project, and so if anyone was actually out there waiting to see this thing done and they're getting frustrated, I apologize. I don't think there's too many viewers of this, honestly, but there might be one or two. I finally was able to be, I guess, at home at a time when 20 meters had some signals on it. And so I was able to test out the radio on 20 meters. I've made a bunch of changes. You can kind of hear a guy popping in. There's a net going on right now. So one of the things that I discovered was happening was the local oscillator signal, I guess, was too strong for the chip. And I was getting a lot of junk. And as far as like broadcast signals, I was getting AM broadcast, shortwave broadcast. I was even getting some weird things like images, and it's a direct conversion receiver, so I shouldn't be getting any sort of images really. So I was just getting a lot of crazy junk, like signals that were just kind of mixing and then remixing again, and I don't know, it was chaos. So I lowered the amplitude of the oscillator signal going into the chip. I put in a kind of a high valued resistor, and there's enough kind of stray RF in this design, the way it's laid out. It's because of the layout, I guess. There's enough stray RF that the chip is still picking up a pretty strong local oscillator signal, even with the big resistor in there. I mean, I can completely disconnect the resistor and it's still getting, pretty strong strong enough 7 megahertz signal that it's able to mix, and I'm able to receive stations. So not the optimum layout, I guess. It needs more shielding and stuff like that. But that's probably not going to happen. Not with this particular project. So anyway, I knocked down that level quite a bit, and a lot of the junk went away. The vast majority of it went away. I still can hear kind of a weak broadcast station bleeding through every so often in the background. And I also put in a bandpass filter for 40 meters and also for 20 meters. I'm going to build another one for 80. And that's what one of my videos before showed. I use this little nano VNA, which is really, really cool. There's a lot of videos. There's a lot of videos on the internet with this thing, so I'm not going to try to do a explanation of how it works or anything, but that's kind of what it looks like there. And you've got a couple of ports here, and you put the circuit between the two cables there, and you can measure how well the filter is filtering. So you can see how well the signal is passing through the filter at various frequencies, and you sweep the frequency across the band of interest, and you can see that when you make a bandpass filter, that it's passing frequencies in the band of interest and it's rejecting the other ones. So it's a really, really handy tool. It's just, I think it was like $30 or $40. It was like really, really cheap. And I've heard a couple of hams actually on the air while I was doing some testing talking about the Nano VNA. And apparently they had one guy said he bought like 3 or 4 of them just to have around. So it's amazing what's out there. I'm sure it's not laboratory grade, but it does give you enough of an indication of what's going on that you can sort of put some filters together. So I think that's pretty neat. So anyway, I had bandpass filtering in there. I lowered the local oscillator signal into the mixer. Both of those things cleaned up stuff quite a bit. It's not perfect. Part of the issue too is just I need to kind of clean up some of the wires. There's a lot of really long lead lengths in there. And in some areas of the circuit they don't matter. In other areas though, it's causing an issue. Particularly with the signal from the antenna coming into the mixer. The longer lead lengths seem to be kind of bringing in more of that junk signals into the circuit. And so I'm going to try to clean it up. Once I get these filters built, I'm going to try to clean it up. One of the things that's also held me back is I've been trying to wind and rewind and re-rewind a transformer to try to convert 50 ohms up to like 1500 for the LM386. I'm sorry, the NE602. I'm sorry, wrong chip. So supposedly the NE602, and it does look that way from the circuit diagram, input impedance is around 1500 ohms, and that's a really huge step up from 50 ohms, obviously. And I was having a lot of really just impossible difficulties to try to find a broadband transformation using toroids. And I don't know why that is. It usually works well on 40 and 80, but 20, I'm not getting the transformer ratio. It's like the core is not able to really function properly. And I don't know exactly what's going on there. I've tried many different cores. I've used cores that I've seen in 20-meter homebrew projects, other radios that other people have designed, and it's still not giving me more than like a 2-to-1, maybe 3-to-1 voltage transformation. I think 2-to-1 is about the best I can get. And when I go down to 40 and 80, I can get 4-to-1, 5-to-1. I mean, pretty much the sky's the limit. But for some reason, 20 has been really finicky. But what I've discovered is the radio actually does quite well, even though that, impedance transformation is really way off. So, I mean, I'm picking up 40 meter or 20 meters right now pretty well. The band isn't in great shape right now. There's a few stations on, but even with my TS2000 Kenwood, I mean, I'm not getting a lot of really strong stations. So the fact this thing's picking up a lot of stations, and, they're not super strong, but I can hear them. I'm pretty happy with that, given the way this transformer's been behaving. So I'm probably going to just go ahead and move on from there. I want to sort of bookmark this issue and try to figure it out later, try to understand what's going on. I mean, maybe the way I'm measuring the transformer, there's a problem with the measurement. I'm using an oscilloscope and a signal generator, but I don't know if there's something funky going on with the signal generator at 14 megahertz. There could be other things going on. I don't know. But, you'd think I should be able to use the same toroids that are used in like a 9-to-1 balun. And so I can research that a little bit more and see how those are designed and try to mimic that. But again, for the purposes of this project, it was supposed to be fairly, straightforward, fairly low part count. I don't know that I'm going to try to rewind it another time. I sort of want to box it up and kind of finish it up and then move on to some other projects. So, but for the future, I need to try to figure that out before I do another one of these. So that's pretty much it. Probably the next video I'll show, hopefully, will be the final product, more or less. I need to work on the 80-meter low-pass filter or bandpass filter. Then I need to put it all together and make sure that at nighttime the broadcast stations aren't just completely destroying me. And if I can pass all those tests, or if the broadcast bleed through isn't too bad, whatever, if the radio is kind of usable, I will box it up and call it good. So I'm going to see if I can do a little quick band scan here before I close it out. And that'll be about it. So let me see if I can pick up something here. I'm going to turn up the volume on the speakers. And let's see. I was hearing a net a moment ago, but I think they are sort of checked out. So November 6th, Oscar Kilo United. So hopefully the phone can pick it up. So there's a speaker up there.
4x5, 5x5, something like that. The estimator on this got you. It's pointed in the other direction, so you're doing very well. Very well. Name here is Bill. We'll give you a 5 by 5. Nice to meet you this afternoon. We're located near Austin, Texas. Go ahead. Yeah, QSL, very good. Well, it's doing pretty good. I just thought I'd say hello. I probably don't want to hold it too long because the connection is not that good.
So I don't know if you can pick it up. There is a little bit of broadcast bleed through that's kind of coming and going slowly. So that issue is going to get worse as the nighttime comes on. A lot of the big shortwave stations start coming online. I think that's going to be the biggest drawback with this radio because I don't know if I completely can cut that out. But you can see it's picking up stuff. You can hear both sides of the conversation. Pretty clear. I mean, it's sideband, digital display. On the other bands, it's accurate to about 100 hertz. I mean, I think I'm pretty happy with this little radio, honestly. I mean, it's not great quality, but it's not a lot of parts. It was pretty easy to put together for the most part. I've taken a really long time to build it because I'm slow and I don't have a lot of free time. But honestly, I think a lot of people could put this together. I'm going to try to eventually put together a schematic and, like I say, a blog post to wrap it all up to kind of show what I did. But it's not exceptionally hard. There's people out there building much more sophisticated receivers, I'm sure. But what I like about this is that the part count is not really super high. I mean, I like projects that are very simple and you can sort of learn about radio and learn about various circuits like the filters and maybe the audio amplifier and winding transformers and stuff like that. I mean, you get a really complicated radio with a lot of parts and you kind of get bogged down and all that. And I mean, I'm not trying to build like a Kenwood or a Yaesu here. So, but when you can build something that's functional and you can receive signals and kind of have fun with it and it works and it's not really a lot of parts, I think that's pretty amazing. So anyway, that's pretty much it. I'm going to tune around a little bit more. This video is getting kind of long, so I don't want to talk too much here. Let's see what else I can pick up. I was going to go down and see if I can at least hear the FT8 down there.
I figured it was because I was using the remote controlled 120 volt switch in the garage to act as my operate standby switch because I was 25 miles away. I figured I managed to mess it up. But I got that question answered today. Operating the 120 volts on and off is just the same as flipping the switch. So.
Some digital modes. Sounds like packet actually, which I was really surprised to hear on 20, but it sounds like there's some packet still going on, which is kind of cool. I haven't heard that in like 20 years. All right, there's my FT8. Very characteristic sound. FT4, FT8. There should be some CW down here. Keep in mind with direct conversion, as I tune, I'm getting both sidebands. So I go down through zero, kind of go down through zero tone, and then you're going to come out the other side. Now, the VFO on this one actually only goes down, I guess, to 14027, so I can't go to the very bottom of the band. That's another thing I need to fix, but So anyway, everything's kind of double wide here. All the CW signals, all the sideband, you hear the upper and the lower side. But anyhow, that's kind of a quick little demo. Like I said, this is going on a little long, so I'm going to cut it off here. Appreciate anyone who's been watching. I appreciate the subscribers. You know, like they all say, if you like everything, you know, give me a thumbs up. And, you know, I sure hope I can post more regularly. That's the goal. But I'm gradually getting this thing done. It really is coming together. And you can see that was pretty clean. I mean, there wasn't a lot of noise there. I didn't even really hear a broadcast station that time. But they're there. And it is kind of a tough issue with this particular design, but it's getting better. So thanks for watching, 73s, and all the best.